So welcome to the engineering room. My name is Dave Farley and welcome to the Continuous Delivery channel. We deliver content on software engineering and topics related to it. And this engineering room episode is part of a regular series which we're going to be providing monthly, where we talk to interesting, influential people from our industry. I'd like to begin by introducing my guest for today. Randy is a well-known conference speaker and a senior technical leader with a background working in many large, sometimes famous Silicon Valley companies, including Google, WeWork, eBay, and many others. Randy currently works as VP of Engineering and Chief Architect at eBay. My first memory of Randy was seeing him deliver a keynote at QCon London on the topic of delivering great software at kind of web monster scale. But since then, we've met several times, and I've always found Randy to be a delightful company and always interesting to talk to. So it's with great pleasure that I welcome Randy Shoup to the engineering room.
Great. Oh, thanks, Dave. Wow, what a great introduction, and so excited to be with you. Really a big admirer of your channel. As we were chatting beforehand, I've watched every episode and just loving every one of it. So for those of you that are not yet subscribers, hit subscribe and like, because this is a great channel to be a part of.
Great, thank you very much. So you spent a lot of your career working, as far as I can see, in big, complex web companies. So I'm interested in exploring your views on what software development looks like when nearly everything that you do is at scale and under the stress of millions of users. But I also don't want to jump in with both feet into the middle of that conversation. So I thought an interesting place to start was I saw one of your talks where you described the different needs of architecture and design at different points in the life cycle of a product. And in it, as a side remark, you said that you thought that in startup mode, you think that a monolith is best. While I agree with that completely, I think that it might surprise some people. So could you explain why you think that's the case?
Yeah, I 100% agree with that. And I love starting small because like every place that's big was once small. And I'm sure we'll talk about all the places that are big, some of which I've gotten a chance to work at, most of which I haven't, all evolved from something small. So every place evolved from a monolith. So yeah, so the way I like to think about it is there's sort of, I change the phrasing every so often, but like there's a startup mode where like I have an idea and I'm looking for a business model, trying to find product market fit. And there, what you're trying to do is iterate really fast. So what you're not interested in is scale, because your team is small and you don't even really know what the bounds of your problem. You don't have to say domain-driven design, you haven't like been able to bound any of your context, if that makes sense. So 100% start with a monolith. That's because you haven't, by starting with a monolith, you haven't pre-decided the subcomponents of your system, right? Like you haven't already, because you don't necessarily know your system to start with. So I recommend in the 95-99% case, people that are just starting out with a project or just starting out with an entire company, that you 100% start with a monolith. And that is true of every one of the big companies. You know, eBay started as a monolith, so did Netflix, so did Twitter. Every place that you can think of, wow, they're really web scale, they all started as a small monolith. So yeah.
Yeah, it's that period of kind of exploring the problem. I'm increasingly of the view that working kind of defensively in terms of design and architecture, so that we give ourselves the freedom to find out where our decisions are wrong and to change them later is important. But also, as you point out, that need to, in the early days when you really got no clue, is to be able to iterate really quickly so that you can learn fast, really.
Yeah, the easiest way to learn quickly is like everything's in a single repo. I can do everything with refactoring tools with my entire with my entire system essentially, because it's just one thing, it's super easy. The other thing is you do not have any of the problems of that services or microservices or event-driven architectures solve. Like all those things, like I'm huge fans of all those things. And where I am now, and I will get there, like we absolutely need microservices and event-driven architecture and all those fancy techniques. We couldn't be large without them. But the problems that those things solve, you don't have when you're a tiny startup iterating fast, trying to find product market fit, and just meeting the needs of your near-term customers. The other obvious thing is like performance, right? So like all calls are local. So you don't introduce any network inside there. It's easy to roll out and roll back because there's one, unit artifact. So yeah, super, 100% the right thing to do. And honestly, I mean, we started with the startup, but like I think 90% of the software on the planet really should be done in a monolith, and it's the exceptional once you're in what I like to call the growth phase or the scaling phase. Then you start to see the problems with the monolith, which I'm sure we'll talk about, and then you can start to leverage into the other architectural solutions for those, and then going from there. But it's an S curve, and like only when you're at the the concave down part of the S do you start to really need to move from a monolith to something like microservices.
I spent some time last week with our mutual friend Martin Thompson, and we were in a pub in Belfast, bemoaning the fact that nearly all projects these days seem to start with Kubernetes and separate repos for everything. And me going, it's not a good place to start.
Not a good place to start. Spoiler alert: eBay is exactly Kubernetes with tons of repos, but
you're not starting.
We're not starting. Yeah, we got 27 years behind us and 4,000 engineers. So no, 100%. It's great. I love to read like, well, what does Google do? What does Facebook do? What do Baidu and Tencent and ByteDance do? And that's interesting, but it's a very small percentage of the industry that has the kind of hyperscale problems. And so
So if you'll forgive me being kind of philosophical and esoteric for a minute, so that leads me to be thinking in terms of I'll be interested in your views on architecture, what you think architecture is and what it gives us. If it's not just about looking at eBay or Google and saying, oh, we'll do what they're doing because that helps. So what is it then?
Yeah, I mean, it's one of those like. Like when you see it. I mean, we've done a couple of interviews where like with Simon Brown and others where we tried to explore the topic of what is architecture, and I don't know I have much to add to that. I mean, there's architecture is the hard decisions. I like to think of it as that it's like, I mean, my mental model is it's the skeleton, of the overall system within which we, place stuff. So but what it's for, my mind is saying tool, but there's, I'm sure, a better word. Like it's just a means to an end. Like there's nothing magical about the architecture. There's no, I mean, this is obvious. There's no one right architecture. There are architectures that are good and not good at, startup scale, growth scale, hyper growth, hyper scale. But there's no one right architecture for everything. And so I would just suggest that it's whatever makes your job easier doing your work. And the one thing that I would add to the discussions I've been listening to is over time, your architecture is likely to change. If you should be so lucky as to like grow into the growth phase and hyperscale phase, you absolutely are going to change your architecture. In some cases, 5 different times. Like that's what we did at eBay. I can tell you that trajectory. So it's totally legitimate to do that. But what is true at every scale is you are going to be changing your software. So what makes it easy to change your software? And what makes it safe to change your software? So, continuous delivery practices, test-driven development and, trunk-based development, all those things, like absolutely yes. But also, what is it about the structure of the system that like matches the problem, right? Matches the problem is isomorphic to the problem, like makes it fluid and easy to make changes because there's less impedance mismatch between the problem you're trying to solve and the thing you're trying to do. And just as an example, again, eBay started as a monolith. So like everything about buying and selling was all in like one ugly process, 3.4 million lines of code in a single ISAPI DLL for our version 2 of the service. But then you could imagine that the next iteration could have been something like, well, buying's over here, selling's over here. And, you could naturally like cleave the domain into two things. And you can again imagine, I never worked for Uber or Grab or Lyft or one of those things, but you could imagine starts as a monolith and then like just naturally cleaves into driver side, rider side. As you think about what's a good architecture for wherever you are, it's just does it match like very naturally the domain that you're working in? I guess I would say that.
I can't work out whether my views are because I'm a grumpy old man and I'm starting to just see the world from a narrower perspective, or whether what I believe is that I think that we are coalescing into something that's the clearer direction. I think I can see routes that are more repeatable, and you said that in the presentation that you went through. You talked about similar the one that I referred to earlier. You talked about similar trajectories for nearly all of the big web shops. They started off simply with these simple things, and then they go through these almost well recognizable stages of architectural choices to meet their business needs at that point. And I think I liked your presentation because it laid it out so clearly. I'll put a link in the description of the video afterwards. But I think that I'm coming to the conclusion that there are lots of these kinds of ideas. My book on modern software engineering is about some of those principles. If you'll forgive me advertising it, I see you laughing. but I think it's trying to get to some of those principles which are fairly deep. Advertising on my behalf, thank you. I owe you a beer. But I think it's getting us to some of these things that are more profound, more repeatable, more patterns, if you like, that we can apply to the software development at different levels that are going to give us a chance of a better job. So applying the wrong pattern in the wrong context is obviously not going to work very well. But you get the right pattern for the right context, and life's going to be easier. Yeah,
let me. I 100% agree on what you're saying, and let me come at it to convince ourselves, like from a entirely different perspective, if that makes sense. All of software is just about solving business and customer problems. I mean, this is an obvious statement, but like I don't think we say it enough to ourselves, and we certainly don't act like it. Right. Our only job as engineers is to solve customer and business problems.
Yes.
Now let's put our job and just put architecture in there. So the architecture that we use to do that is entirely to solve business problems. And so what does that mean? It means, so back to what I was saying before, like it should match our domain in a very natural way. And it should make it really easy for us to evolve over time in response to those customer needs. So every time I see, and I've been a part of these too, every time I see these like generic conversations about software architecture, I'm like, y'all missed the problem statement. Start from and what's uncomfortable is that like everybody's everybody's particular customers and particular domain is different. So it's hard to say general stuff, maybe. But I think you can never go wrong with starting from what's the view of the world of the customer. In other words, what's their domain and, domain-driven design, and like use that as the organizing force for your architecture. And if it meets what your customers need, it's the great architecture. And if it is offset, if it goes in a different direction, if it like doubles down on dimensions of problems you don't have, like like trying to solve scale problems, or high performance problems, right? Like, with all the LMAX stories that you tell all the time, like that is awesome. And also that's a 0.001% of the, this is at, that level of, microsecond performance is a 0.001% kind of problem. And that's not dismissive. That's just like reality. So the kinds of
it wouldn't be worth, I don't know, somebody doing, a web app for their mom's cake shop to be doing performance testing like we did. That would be ludicrous.
Or to be frank, we do performance testing for us all the time, but we don't measure it at microsecond scale because our customers are humans. And humans work at tens of milliseconds, not at single digit microseconds. And so absolutely, for us, I love the disruptor pattern and all the techniques you all discovered and invented. And also, when I have that problem, I know I can go reach for it, but I don't have those problems, right? Even though I'm at big scale, like I don't have that kind of problem. So anyway, so understand the problem. Yeah, sorry. Understand the problem that you're solving, like as a business, your customers, and then for the most part, your architecture can just flow from that. And again, and then like you say, as your customer, particularly for like web scale consumer oriented things like the Googles, the Netflixes, the eBays, the Amazons, they all have co-evolved in the same direction because the problem statements are super similar. Right. Again, everybody started as Amazon too, started as a monolith, and over time that got creaky and horrible, and broke up into individual services, a small set, then more and more and more and more. And I don't know Amazon now, but I'm imagining it's in the order of 10,000 services. eBay did the same trajectory, start as a monolith in our version 2 of our software. Version 3 was break up into Java mini applications, I'll call it. So about 200 different applications, each that kind of directly take parts of the site, buying, selling, search, payment, etc. And then now it's 4,500 or so different, services and applications that are at smaller granularity. And again, Netflix did the same trajectory, Twitter did the same trajectory, etc. So if I can replay what I think you were saying, is that customer focus is all, of course. I think we definitely agree with that. Just as a sidebar, one of the commonest pieces of advice that I give to my clients, who I'm helping to adopt continuous delivery in the engineering practices that I talk about, is to fix the requirements process, because nearly all of the requirements process is trying to do kind of programming by remote control, expressing technical ideas rather than focusing on the customer outcome and what the software is really for, which is, if we don't get that into our thinking, into our optimization, for everybody, then we're probably not going to do as good a job. But the other thing, coming back to what I think you were saying, so you led by the customer, but the principles that I also think is that I think there are some fair fundamentals that just keep the doors open. So when it comes time to make the move, to the next stage or whatever that might be, whichever direction you might be taking, it's just going to be a little bit easier. Yeah. So if that's a ... that I can fill in. So I'd love your thoughts. Let's go back and forth on this. But off the top of my head, with some consideration, how can I make my monolith more easily like scalable, right? Yeah. So think about it as modules or components, right? So there are natural subdivisions within your monolith. And reify those in whatever the component model is of your favorite, the language that you're using, right? So they're separate jars, they're separate DLLs, they're shard libraries, whatever. And the fact that it's a monolith means it's when, not if, we make a mistake in our initial domain decomposition, we can easily change it with no big deal. But still having reifying that domain decomposition inside the code, super helpful. Critically helpful. The best, well-structured monoliths, as Simon Brown would also say, I think, would put a lot of modules in there. The other thing is really good monitoring of what's going on in the real world as it's being operated, right? And part of that is just like, I want to understand how the system is behaving so I can look at where are the points of, single points of failure, performance bottlenecks, et cetera. But equally important, maybe more important when we're in that kind of, flatter part of the S curve or startup phase is I want to understand user behavior, right? So there's a good amount of stuff I can do by like talking to customers, which is great. We should definitely do that. Yeah. There's a lot of stuff that the customers don't know that they like can't say or say, or we can't talk to them for lots of other, lots of reasons, can't talk to them at scale. And so monitoring for usage, hugely important. Again, that helps you figure out how to I kind of say, oh, well, when you get there, you can it naturally cleaves into domains. And I've always found that, to be honest. Yes. Not because I think I'm lucky or really any good. It's just like, I think that's just a thing where like, as you get to a certain, size, it's like, oh, it's kind of fractured. It's like a big boulder, like it fractures along this, this line
fault
here.
line.
It's a fault line. Exactly right. Yeah. It's fault line software. Although I think that implies, particularly in California, that implies that,
something else.
But no, all good. Anyway, but my point is that really understanding customer behavior in a detailed way is a great way of seeing where the opportunities are. And then I know you know this, but like one of the book that when I joined Google, everybody was encouraged to read was Michael Feather's Working Effectively with Legacy Code. There's so much great stuff in there. I just reread it about a year ago, and it's tremendous. Whatever, 20 years old at least, but like still just as fresh. But the idea of a seam. So as you have this monolith and it's creaky and big, and you want to figure out how to modularize it, either within or like to take something out, is you're trying to look for and sometimes make a seam in your inside there. And that's just a way of saying you're abstracting away, information hiding one part of it from the rest of it, with the goal of maybe potentially being able to, move that out into its own, separate process or service or whatever.
And absolutely. I'm about due for a reread of Michael's book as well. It's a fantastic book. But on that idea of seams or fault lines, I in an earlier episode of the Engineering Room, I talked to Kevlin Henney, and one of the things that he said, which I really liked, was, in that phase where you're all kind of stood around a whiteboard and you're all kind of bouncing ideas around to understand the problem, he says, as soon as somebody says we don't know about this bit, there's a seam, there's a line, there's a place to hide stuff because you don't know enough about it yet. Right. And I thought that was, and I realized that's something that I did myself, but I'd never thought about it in that way. Now I think about it in that way all the time. It's a really nice way of thinking about identity, another way of identifying those things. I use the kind of bounded context stuff, the domain-driven design ideas, and have done for versions of them for a very long time. But I liked that idea of kind of drawing a boundary between the stuff that you're sure about and the stuff that you're not, because that does represent, one of those joins somewhere.
Exactly. Yeah. And not to introduce a new concept, but like the fact that you were able to get your job done and you were able to limit your cognitive load to some particular area of the code and not consider the rest of it. Again, I'm just reinforcing your point. That's clear. So clearly there's, I don't know anything about that payment part of it. Okay, great. Like that's just a theme. I don't know anything about the, how the inventory gets in there. Okay, great. That's another 100%. That's really insightful, actually.
Yeah, I really liked that when he said it. I think there are a few of those kind of, if I think about it, there's a few of those kinds of rules of thumb. There's kind of Eric Evans stuff about bounded context and so on, which is an obvious starting point. I think one of the things that I came to believe fairly profoundly from LMAX was a good set of default seems is between the accidental complexity and the essential complexity, which kind of reinforces some of Eric's stuff. You want little bubbles of domain logic that aren't polluted by concerns of accidental complexity, really.
Right.
And then then you've got this other stuff, about Kevlin stuff about the bits that you're not so sure about, or you're a little bit worried about, and you'd like to just build a little wall between you and them. And I think if I think about it, those are all kind of realizing the sorts of principles that underpin the way that I think about design.
Oh, that's lovely. Yeah, that's really great. Like I'm seeing it in my mind as two different dimensions, right? So there's there's one dimension that divides the domains or the subdomains from each other in that way that Kevlin saw us help us to see. And then there's another vertical division between you're calling it essential and accidental complexity. Another way to say it is the domain logic or the product logic and the platform and infrastructure, right? What surrounds it, and the random choice. Okay, what database did we choose? Like, are we running on Kubernetes? Like all that stuff that should have nothing. I mean, does the customer care? The customer does not care. Therefore, that's another part of it. There's a third. I don't want to flip out of this too quickly, but it makes me also say there's a third element, which is about asynchrony, which is and the way to think of the another. I think it's even a third dimension, if I can say it that way. Like, does this operation need to be at the exact same moment as this other operation?
Yeah.
Right. Do they need to be atomic? Right. Does there need to be a transaction around those things? And most people, when we're both old and grumpy, like when we started, oh my gosh, yes, what are you talking about? Like you're committing heresy by like not having everything be all transactional. And then we started building big systems, and it turns out, well, no, actually, this thing can happen over here. And then just like the real world, there's a little bit of delay while the event gets propagated from point A to point B, and then point B reacts to that in some eventually consistent way. And that is the other unlock, mental unlock, as you're going up as you're ascending that scaling curve, is
absolutely
everything all have to be all the same, or all at the same time, right? So as an obvious example in eBay, as I've used this particular example for 20 years, when a seller comes onto the site and lists her item, does that immediately have to show up in the search for buyers? I mean, it'd be nice, and like it only takes a second or two because we worked really hard on that. It's not okay to take 8 hours, which it used to. That's super not okay, by the way, in no scenario. But it takes a second or two. That's not a big deal to anybody. And the difference between it's immediate and it's a second or two is 10x of hardware and hair pulling and and everything like that, right?
And the explosion in complexity. So it's one of the things. I think this is probably one of my heresies that not many people agree with. But another thing that I came to believe from the LMAX experience, something that Martin started saying as well, I think he kind of reinforced from the LMAX experience, was that synchronous programming is the crack cocaine of programming. It's kind of completely addictive and really bad for you on the whole, certainly at scale. But I think if you look, as you mentioned it in passing, but I want to reinforce the point. If you look at the real world is not synchronous. When we are talking to one another, your brain is not freezing while I'm speaking, and mine is not freezing waiting to respond while you're freezing. We don't stop the threads. You're stop thinking about other stuff, and you're probably thinking, oh, I'm going to go for a walk the dog later, or something else if I'm being boring, and planning what you're going to do later. And there's loads of stuff going on all of the time. We're all just sending messages, asynchronous messages, really. And I think that goes quite deeply. I'm a physics nerd, and I think you can think. There's some theories of physics, fairly deep theories of physics, that say that nearly everything is just information, and everything's just certainly the standard model of particles. You've got force carriers that are essentially little messengers that take messages although they're very, very simple messages, between other particles. And I think the synchrony thing, we all learn it first, and that makes it feel safer. But actually,
it's wrong.
I think it's wrong. And one of the things that we learned building the LMAX exchange was that actually, making everything asynchronous made our life hugely easier in terms of scalability and so on, but also that separation of the accidental and essential complexities.
Exactly. That's why it's that third, of the dimensions we mentioned of separation.
Yeah.
That's why it's the third dimension. We're decoupling the two things in time.
Yeah.
And means that whether we're using an actor model or a disruptor or just, Kafka messages, between service A and service B, it's all the same concept, which is,
yes,
I do my job A, and then I let somebody else know, and I'm done with that part. Yes. And then at some time later, maybe microseconds, maybe nanoseconds, maybe minutes or hours, B receives the thing and reacts to it, and so on. And I think it is very, very deep. I am actually a physics nerd too, so and when I don't want to get too into it because it's kind of boring for everybody else, but the force carriers only go at the speed of light.
Yeah.
Right. So it's, that's why relativity behaves in the goofy way it does. And we're still trying to figure out how to get quantum mechanics sorted out. It's anyway, but it does match the real world. It matches the real world of subatomic particles, like you say. It matches the real world of human to human interactions, like you say.
Yeah.
We are both parallelizing, we're having a conversation. We're also doing potentially other things, certainly autonomic things in our, in our bodies, and I'm drinking my tea and all that kind of stuff. But also, just to belabor the point, our conversation is itself asynchronous messaging, right? So when we started this, we figured out our delay is somewhere in the hundreds of milliseconds, between because we're over a continent and an ocean, between one another. But also, it's literally, I say a thing, and then it travels those, 10,000 miles or whatever, and then you hear that thing and you react to it, and then you say back. And so we're having we would call this a synchronous conversation that we're having, but it's actually made up of asynchronous messages.
Yes. And again, and all of them are at every level, always. That seems to be true.
There's no part of this that's synchronous, right?
Yeah.
Of course, the TCP layer upon which we're having the conversation, exactly the same. Like TCP gives us this, there's actually a synchronous conversation there. That's at that level of the network stack. But actually, that's not how it works. It's it's asynchronous packets going back and forth that get reordered, so that we have this illusion of synchrony. Anyway, so pop. Okay, let's talk back to software architecture. So it's not like, I'm 100% agreeing with you. It's not just, when I get fancy, I'm going to do things asynchronously. It's like, actually, if you really model your domain, it's asynchronous.
Yeah.
So what that does is that gives you a lot. Like you say it removes complexity. I think that's absolutely right. It makes us not have to think about a bunch of things at once, but it also gives us the flip side of removing complexity is it gives us more degrees of freedom.
Yes.
So again, as I gave a random example of somebody, not random, the real world example, hopefully visceral example of somebody listing an item on the site, and then sometime later, it shows up in search and is available to be bought or bid on by somebody else. When somebody lists a new item, there's one event that happens from that, or there's a series of events, but like one, item listed event. And then there are like 10 or 20 different, entirely separate processes that get kicked off from that. Like, let's take the image that she gave us and thumbnail it in all these different ways. And then let's check it for various aspects of fraud, because that's the thing, and blah 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 blah, increment and decrement a bunch of stuff about her seller account, because now she's sold 1,000 things, and there's literally 10, 20 different asynchronous processes that are going to kicked off by that event. And again, just the mental freeing of being able to think of these things as separate ideas,
Yes.
slightly connected in time, as opposed to it all has to happen in one.
Easier to test, easier to deploy, easier to manage, easier to scale.
100%. 100%.
All of those things.
And also, since we're, there's also decoupling the availability of the two things. So she can list her item, even if, God forbid, the search engine is down.
Yes. Yeah.
Right. That's not, there's no transaction that says, oh, well, she can only finish listing if I add it to the search engine and also check it for fraud at the same time. And I also thumbnail all the images and do all these other things. And that all happens in one atomic go. That's not how it works.
Yeah. And I think that kind of big ball of mud, single go is almost the inevitable end point of that kind of synchronous thinking, unless you are experienced enough to have messed it up so many times that you're wary of it. If you just kind of walk into it, you almost inevitably end there.
Yeah, and we just have to ask ourselves, as we hit a problem that's associated with scale, we have to ask ourselves all these questions.
Yeah.
Does really need to be the same component? Does A thing need to be transactional with B thing? Can we decouple them? And 95% of the time, the answer is yes, you can decouple them. And then you go from there. And it's so freeing, because again, it makes the individual components so much simpler and more scalable and more reliable and all that. So
and I think that one of the freedoms that the asynchrony and essentially the eventual consistency model that you or no consistency model, one or the other, is that by not having, I think it's what you were touching on in your presentation when you were talking about the microservices first being more coupled, allow you to move really quickly while you've got, sources of truth, and you can bring things together. As you said in your IDE, you can spot where there are differences and so on. But then as you learn where those boundaries are, you can start to pull things out, and you start using a more event-based organizing principle for the ways in which these things communicate and share information. Then essentially what you're doing is you're denormalizing the information, you're denormalizing the data so that each bit has got a local copy that it can operate on. I think in the presentation that I saw, you gave an example of I can't remember which example it was now, but there was an order. There was somebody with an account, and they were adding some orders to their account.
Yeah,
that will do well enough. And so, you could have something else that's listening for the creation of accounts and the creation of orders and the association with orders of accounts to build the join, to build the picture that puts those together. And that's a copy of some of the information. So you need to think about how that changes, but that's very natural in an event-based model.
Yeah, exactly. Yeah, it's hard to. Yes, I 100%. Yeah, so it's Stitch Fix, where I also led engineering. It's a clothing retailer, and so one of the main idea of customers is getting their preferences and sending them boxes of clothes. And so the example in the Stitch Fix use case is we would send somebody an order which contained 5 items of clothing, each of which they prefer or don't prefer, right? So it's itself a little group of things. And so the example that you were talking about is we have events about the client has received the order. Okay, that's one thing. We shipped it, and there's a whole event source, what happens to we picked it, we packed it, we shipped it, it arrived. She confirmed it, the client, and then and there's a bunch of metadata associated with that thing. But then each individual items itself also have metadata about them, right? So there are pieces of inventory. There's also she likes the blue dress, she doesn't like the black belt, she somewhat likes the leather shoes, whatever. And we want to join those, for reasons we want to join those things together. And the way to do that is to have events that are about that order entity that we're listening to, and then events about those item entities that we're listening to, and then a service that is listening to both those events, and then materializing that view, essentially, constructing that join of those two things. And then, to your point, we can very easily construct that here, show me all my orders page, essentially, right, for her and for other use cases. And like you say, 100%, that's a denormalization, right? That's a cache. That's a there are systems of record about the orders and about the items, and this materialized view over here is not the system of record for either of those things. And also, it's a totally useful model or entity in the system that we want to have, right?
Yes.
So we just have to, so we construct it and update it through listening to these events, and then we leverage it. We use it, to like paint the order page or whatever, and we go from there. But yeah, I mean, and how do we get there? It's because we built up those things as individual components, like that the customer, there is an order for the customer, there is an item for the customer. Those are real physical things. And then there's also this virtual thing of, I want to show all the orders for that particular customer, or something like that. Like, that's also a thing for the customer. And so if that's a thing for the customer, it's very likely that it should be a thing in our system, right? And so and that you said that these are real things. These are not artificial constructs necessarily that we build for technical reasons. They're part of the problem that we're solving. They're things that we need to solve the problem that we're dealing with. We did something very similar in the LMAX system, where, to kind of pull out the eventual consistency thing, was I very like eBay, I assume, is that, at the point at which you're actually doing the auction, a market is just another form of auction in trading. So at that point, you want that to be fast and efficient and focused on prices, close together. But actually, the history of what orders that I dealt with, or so on, that can happen sometime later. It doesn't matter if that's a few seconds being realized to be visible later on, if you've just won the auction, or you've just sold an item, or whatever it is. That history can come a little bit later. It can be a little bit delayed, and you get these much more nicely compartmentalized systems. Yeah, 100%. And actually, to double down on that particular example, which is great. So the vast majority of eBay is eventually consistent to other parts of it. You mostly don't notice, because, again, at human scale, things are happening. The machines are faster than we are. So for the most part, you don't notice that. But, and I'm going to keep throwing in new things. So there's the CAP theorem, which is about be consistent or available in the face of partition. So Eric Brewer proposed this, you can't have all three: consistency, availability, and partition tolerance. But the better formulation, which he would say, is you are going to be partitioned. So when you're in a weirdo case, are you consistent? In other words, do you block everything, but you might be down? Or are you up and potentially not consistent for some short period of time, right? So eventual consistency is that AP solution. It's in the case of partitions, we are available, which means, we're not consistent. So this part of the system over here knows that she had the item or made the bid or whatever, but this other part that, paints the summary or whatever doesn't know that yet, right? Okay. The place, or one of the very small number of places at eBay that is CP, consistent, and in the face of partitioning, but not available, is exactly the auction. The auction thing. Why? Because the core part of the auction is that only one person can win. And every bid, people know this, but like every bid builds on the previous bid, right? Like I can't, if the current price is at 25, like my bid of 24, sorry, that doesn't work. So there's the problem domain tells us that it needs to be serializable, that there's all the bids that are coming in need to be put in a particular canonical order and dealt with in that order. So if at the end of an auction, as happens, like you quickly throw in a 29 and I quickly throw in a 28.5, even if my 28.5, even if they arrive in a different order, like there's a well understood, way of like resolving that conflict. But if that particular slice of the system, that particular database, relational database that like remembers that thing is down, we're done. Like that auction isn't happening, for in that moment. And we figure out other ways to deal with that. But we don't hide it. If that makes any sense. So like that's a place where, and this is exactly your point, where the order book way down deep in inside a trading system is exactly that. Like it has to be single threaded. It has to be very deterministic. Anyway, so yeah.
Interesting stuff. So in general, I think that the consequence of one of the things that we were just talking about then is that, apart from those very special cases, if we are talking about doing computing at scale, then AP is the more scalable route. That's what most of the stuff we like it. We prefer it to be like, probably.
Yeah, 100%. Yeah. And again, we're throwing a lot of terms at people, which I hope if they're not familiar with them, I hope they'll look up. But recognize that when we're saying AP, we're equivalently saying eventual consistency, and we're equivalently saying event driven.
Yes.
I know you know that, but like, just whatever. Dave and I have used 3 or 4 different terms, trying to come at the same idea, and we're saying 100% all same thing. And again, to talk about those rare cases, the 5%, 1% of cases where we really do need to be CP, we need to be serialized and ordered. That's where we use transactions. That's where everything has to happen in a single component. And that's where, if that particular component happens to be down in that moment, correctly, we say, sorry, we can't, we can't do this auction, right? We can't take this order. Yeah. Okay.
Or single-threaded with a disruptor, maybe, just instead of the transactions, but synchronized, certainly. Yeah. So we've probably been enjoying ourselves too much talking about our favorite topics. There's more favorite topics for us to explore. So beyond that, I think we've probably talked about some of the architectural things and the technical things of scaling up a little bit. We've talked a little bit about the journey and those sorts of considerations and how those considerations change. What other kinds of problems do you face when working at eBay scale?
Wow, lots of them. I guess I'll start from, so we not only have lots of pieces of software, we also have lots of people. And we would like to make all of them more productive than they otherwise would be. So like 4,000 people, that's not one team. I mean, this is kind of obvious. Like I'm almost making a joke. And so therefore, part of the organizational structure dual with the architecture at eBay is, how do we figure out how to use 4,000 people effectively, essentially. Mm-hmm. And so the modularization, information hiding, componentization, idea where we break into these, that's why we have 4,500 services and applications, right? It's in many cases, it's because those individual teams need to have this, bounded area that they work in, and they do their work, and hopefully it's independent of, other people's work. Mm-hmm. That's a big one. I don't know, what other things would you like to explore?
One of the places I'm interested in kind of taking this, I guess, is thinking about things like technical leadership. You're chief architect and vice president of engineering, so it's your responsibility ultimately to kind of own the technical direction, presumably, for many of these choices. So that's something that I see so many organizations struggle with. We're still working on it too, actually. Which is the fun part of my job. So I am the chief architect. What that does not mean is that every decision, or even every architectural decision, comes to me.
But I mean, like, but one might think otherwise, right? Why does Randy approve all the things? Like, nope. Most of the things Randy doesn't even know about. But it is my job to make everybody, again, back to what architecture is all about. It's like enabling the teams and the engineers to do their job more effectively than they otherwise would, right? And so my main focus is in this moment, honestly, less on an architecture or re-architecture of eBay and more on using continuous delivery principles to make the teams more productive, right? Mm-hmm. So that's actually what I focus on. And then the VP of engineering part of my job, my day job, if you like, is building and maintaining the developer platform that those 4,000 engineers use to do their jobs, right? So I'm in the platform and infrastructure kind of side of eBay's engineering organization, and my team's customers are all the engineers that are building the customer-facing applications and services, essentially. So we build and maintain the frameworks that we use. We're heavy users of Java, have been for 20 years. Heavy users now of Node for the front end stuff. And my teams build and maintain those frameworks. My teams build and maintain the CI/CD pipelines, so we're, make it easy for teams to build and test and securify and, make accessible and make performant all the services and applications that they use. One of my teams is responsible for the external APIs. So there are a bunch of third parties that, leverage eBay programmatically, essentially to, bid on things, to buy things, mostly to add inventory to the site, all that stuff. I have a cross-functional program management organization that helps with, big, hairy, cross-domain, cross-organizational programs. But essentially my teams are enablers, right? So if you think, team topologies, my teams are all platform teams and enabling teams, right? So I guess I don't know if this is where you wanted to go, but a thing at scale is you need to have that team, right? And it's true. Interestingly, the bigger scale you are, the larger percentage of your overall engineering investment is going to be associated with whatever you call it, the platform or the infrastructure, that type of thing. And so there are some companies that are at 40, 50, 60% of their engineering investment is one aspect or another of the platform. Why? It's because as things get bigger, it gets harder and harder to keep everybody productive. And it's more and more valuable to, like, the advantage to making them productive, the benefit of making them productive is that much more. And so that means that, the organizations that are effective at large scale, again, the Googles, the Amazons, Netflixes, have all invested a huge percentage of their engineering effort into making the teams that do the customer facing stuff more productive. I hope that makes sense.
Yeah, it does. The bit that I see large companies struggle with very often with that is in sufficiently decoupling those platform services and so on from application production. How do you what sorts of things? I'm leading the witness because I'm trying to set you up for answering it with what's going through my mind. So what sorts of techniques do you use to try to avoid one application team asking for a new feature from the platform and then forcing a change on another application team?
That's a good one. We're still learning to be better about that. To be perfectly frank, like we're not perfect. We're still learning and getting better. I will partially answer that question, then you can lead me in another direction. But philosophically, my team is just like a vendor inside of eBay. Like our paychecks come from the same place. We all have the same badges and the same color badges, whatever, when we used to go into the office. And also the correct interface or the correct interactions between my team and the customer facing teams is like a vendor customer relationship. Yep. So now answering your question, I'll reframe the question slightly. How does the platform team prioritize between various different things they could do? Because by the way, we're getting requests from the customer facing teams, we call them the product engineering teams or the domain teams. Yep. We're also getting I wouldn't say an equal number, a larger number from the security group, from the infrastructure group, from all that other stuff. And so we do have to prioritize among all those things. In that case, we put our eBay hat on and we look at all the, we look at the kind of costs and benefits of those different things and what unblocks whom and how important, it's like important and urgent, that little 2x2. What's in that, like both are important and urgent box, like we kind of do that first. So that's a little bit how we decide among the many competing things that we do. But if we can always keep that hat on about we're just a vendor, so number one, that makes it a little bit clearer on the product thinking that we could have, like what would an external vendor do, right? Like how would they approach this problem? Anyway, I lost my other thought, which I'm going to come back to, I'm sure, when I re-remember it.
Sure. I think one of the implications, I'll ask it as a question because I'm not sure that you said this, but one of the things that I was taking from the way that you were describing that was working as a platform team. You're not thinking that you're not specifically targeting end user function. You're treating domain applications as your users, and you're servicing them. That's
exactly as Amazon Web Services would do, Google Cloud, Heroku would do, Google App Engine, which I used to run engineering for, would do. It's what is it? What's the mental model of the developer platform? It's making easier the job of the individual developer. So that's that's our goal.
I led a much smaller team in a trading company a few years ago, and one of the things that we used to say was our job isn't to force people to use our stuff. Our job is to make stuff that's so good that everybody wants to use it.
I almost exactly say the same thing. The way I like to say it is our stuff must be strictly better for the team than building it, buying it, borrowing it. Strictly better. I can go. I actually will go off on a small little rant about this because it's very common for companies to build some shared service or some platform and implicitly or otherwise force everybody to use it. Right. And that is, I 100% understand the emotion where that comes from. But it's a sunk cost fallacy in some sense. Like it's well, we built this thing, we invested in the XYZ platform, so you all should use it. The problem is that particularly at scale, it makes the incentives wrong. Because as a platform provider, I'm actually not incented to make the very best thing. I could do other things, hopefully I'm a good person. I try to be a good person, but by having a customer of mine, an internal customer of mine, have the choice between using our framework or something else, that actually is the best incentive for them because they're choosing exactly the right thing to make their job better. They have full control over their lives essentially, and they can meet their customers' needs, like eBay's external customers. And it also gives me the proper incentives to do that. I'll say openly that eBay's kind of in the middle there at the moment. So we're more on we do have these common frameworks, and we do strongly encourage people to use them because they get updated very regularly, patched in all these different ways. They're actively maintained by our stuff, et cetera. So we make a big investment in those things, but we do allow teams to go their own way. But it's a big burden on them because they have to, and some teams don't really fully appreciate, they're like, yeah, but like they don't appreciate the long term. It's like free isn't a puppy. Do you know what I mean?
Yeah.
Like, it's a big commitment to say, you know what, we're going to do. I mean, there's nothing wrong with the examples I'm going to give, but like, we're going to build our thing in Python. Yeah. And okay, I mean, Python's wonderful. Like I shared an office with Guido at Google. Like I love the language. And also that's not what we support as part of our particular, framework. Yeah. And so, all right, well, great. So when you decide to do that, it really better be better for you, because now you're up for upgrading Python. Now you're up for fixing all the security issues. Now you're up for integrating with the monitoring system, with the deployment system. Yeah, all those different things. Like this mythical other team that chose a different path, you've taken on those responsibilities to do all that. So the way I like to say that, we don't really say this internally, but the way I have liked to say this in the past is, you must be this high to ride this ride. You must be this high to go your own way in the framework. Anyway, so a bunch of organizations make entirely different trade-offs there. Google is traditionally more, it is a choice, and also it is the very, very common choice for everybody to use the full suite of Google services internally, because they are just tremendously good. Yeah. We're maybe a little bit in the middle there. Then way on the other end of the spectrum traditionally are places like Amazon, where it's, there's way more, just what I've heard, like it's way individual for the individual teams, way more diversity in what they do. And, these are all legit choices to make. But at the end of the day, a team that makes a choice to do a thing, to like leverage a particular stack or a particular framework, they're taking on more or less responsibility based on whether they're using the kind of standard thing or not, right?
And it's one of those things that platforms are useful for kind of allowing teams to focus on the essential stuff that they need to care about without worrying about that quite so much. Organizationally, it seems to me that a big organization, you want some level of freedom for the heretic teams to be able to experiment with other things, because contextually they might be right. What they're doing might be better, or maybe they've got a problem that's different. One of the trading companies I worked in, we had a team that was building FPGAs, and the off-the-shelf deployment pipelines that we were building didn't fit them very well. So we helped them, but they did their own thing largely. So there's that kind of stuff. But as you say, you've got, when you make that choice as a team, you've got to recognize the whole gamut of responsibilities that you're taking on as a result.
Yeah. So the seemingly contradictory, but I think entirely compatible claims I'm making is that at scale, you want to invest in a common platform or set of platforms because of the leverage that you get. And also, you don't want it to force people to use that, because to your point, there's an evolutionary, there's like economic incentive for both sides to like, well, choose the right thing for my use case, which may or may not be the platform. And then also, how does the platform evolve if everybody's using it? Like you just decided, we pre-decided there was some, if we do that, we pre-decide there's some monoculture and we never explore anything else. Yeah. So the common industry phrase, which I know you've heard, is the paved road or the paved path, right? Yeah. So Google and Netflix are both famous for that, for the choice of individual consumer teams to being able to choose what they use or not. And that has wonderful like long-term effects about evolving the thing. I actually will give us some eBay examples. So, the majority of people use eBay through their mobile devices. I certainly do, right? So our iOS app and our Android app. And only relatively recently have the UI frameworks, the standard UI frameworks become really, really rich. So that's SwiftUI on the iOS side, that's JetPack Compose on the Android side. And so we are now, and we've had a mobile app for 15 years. And so we built a bunch of our own stuff, which is non-standard in the industry, because the industry stuff was either not there at all or, wasn't mature enough for us to fully leverage. Now that has flipped, where the industry stuff is pretty great. And so we're now piloting with a couple of willing early adopter teams, leveraging, SwiftUI and the iOS app for parts of it, and Jetpack Compose for other parts of it. And what they're seeing is there's a huge, it's very, they get a lot of productivity out of that. But if we had continued to say, so it's great, like so far the pilot looks fantastic. It's a great experiment. Like we're looking forward to doing more and more. And my like mobile framework team is working closely with those things. So there's no competition there. Although it is a choice, right? There's a choice for teams to like leverage the A or the B. But that has wonderful effects because now the teams are able to leverage, a bunch of industry knowledge, and those things are now they'll continue accelerating because there's way more investment in them. But if we had forced, as some organizations and even some people at eBay would have liked us to do, if we had forced teams only to use our framework and never explore the new mechanisms, we've made our things too rigid, and we've given up major opportunities to be more productive and leverage other people's.
And as you said right at the beginning of our conversation, it's all about the outcome.
I think at the end of the day, like no customer is saying, well, I really like, I found a great deal on this thing, but like, I hate that you use Jetpack Compose. What said no customer ever, right? And actually, in the other area that's super similar is GraphQL. So that's pretty standard in a bunch of different areas. Developed at Facebook, leveraged at Netflix, and many other places. I guess I'll call us the late majority. We're just starting to adopt GraphQL. We've solved that problem in an entirely different way. And also we're seeing, wow, like it's super productive when we're able to leverage, one of these other more industry standard things for lots of reasons. There's more tooling and there's more investment.
Sorry, I interrupted you.
I was just completing the thought. So that's just another example of where, again, we could have been so rigid to say, you can only use this kind of bespoke eBay technique to how to compose complicated stuff, but we would have given up. It's like penny wise and pound foolish. Like, oh, well, we made investment in this thing, so we should like recoup that investment. And again, I understand the emotion behind that, but like if you think long term, you really put your eBay hat on, it's actually correct for us to be exploring these other things, and when they're great, experimenting with and piloting them, and then leveraging them when they're really good.
I used to see that anti-pattern of really rigid dictated architecture from the top, or tooling from the top in banks and financial institutions very often. And we used to call it architecture by golf course, because some bloke would go to the golf. It was nearly always a bloke. He'd go to a golf course and do some deal with the salesman from some software vendor, and that's why the architecture was fixed that way. So let me just paraphrase the thing that I think that you're saying is that really the technical leadership at that kind of level in a big organization is about establishing guide rails that are going to encourage people to follow the path, but you're going to allow bungee jumping sometimes.
Yeah, 100%. You say it much better than I did. But yeah, 100%. The goal, again, pop. Our job is to solve customer problems in a straightforward way that's sustainable for us as humans, as human engineers. And by the way, if we can solve the problems without software, that's fine too. So our job as engineers is to solve problems, break them down, solve them. And so therefore we need to continually be open to, different ways of, the way that we solved it 5 years ago, that was probably it was a good decision and it seemed legit at that time. And now we have different options, and so we should be a little bit open, not a little bit, we need to be completely open and humble about, if we made this decision, in 2022, what would we do? And if that decision is different from the decision we made 5 years ago, all right, well, what does that mean? Do we start to do a pilot of that new thing? How would those things interact together? We have those conversations all the time.
Yeah. So I know that you're busy working on improving your continuous delivery approach at eBay. So let's talk about the Velocity Initiative. Could you describe a little bit about what it is that you're doing?
Yeah, sure. So I returned to eBay. So I was at eBay from 2004 to 2011 in a mostly individual contributor role. I spent 10 years doing other things, like you mentioned, Google, Stitch Fix, WeWork, other places. And then I returned to eBay just about 2 years ago in the beginning of the pandemic. It felt like in the middle, but like we're still in it. So like in June 2020. And more or less what I came back to do was to help eBay modernize its software approach. So the problem statement is like, okay, we got 27 years of software. We just want to be faster. We want to be able to, again, it's all about solving customer problems. We want to be able to solve those customer problems more quickly, more sustainably for our people, more efficiently, more effectively, et cetera, right? We want to both build the right thing and build the thing right. So there's universal agreement that that's a problem, that we have, and lots of other places have it too. And I was excited to come back and do that because I love eBay, the company, I love the people, et cetera. Also, I feel like 10 years on, I have more tools in my toolbox than I did before. And so we put together what we call the velocity initiative. And like, I kind of inherited the word. It's not the perfect word, but whatever. It is what it is. What it isn't is like everybody working harder. That's
a good thing.
But yeah, so problem statement is we want to go faster through the product development lifecycle. Yeah. I did an initial set of what we call value stream maps in Lean. So I looked for a couple of different teams and like, tell me about your product process. Tell me, how does an idea become a project? How does a project become committed code? How does the committed code become a feature on the site? And then how do we iterate on that feature, with analytics and experimentation and so on? And very quickly, we discovered that the bottleneck at the moment for most of the teams at eBay is the software delivery part. So how does committed code become a feature on the site? And so that's all aspects of when a developer is done, what does it take for her excellent work to make it to customers? And so we did a pilot with about 10% of teams in 2021 and started applying all these continuous delivery techniques. So we worked in tight feedback loops between my platform and infrastructure teams and what we call the domain teams, right? The product engineering or like customer facing teams. And we would ask everyone on this simple question. So it looks like you're deploying, we use the DORA metrics, which I'm going to come back to. So on deployment frequency, we look, we will ask a team, hey, it looks like you're deploying, once or twice a month. If I told you you had to deploy every single day, tell me all the reasons why you can't.
Yeah.
Teams were so excited to tell us all the reasons. I mean, 10 to 20 reasons. The builds take too long, testing takes too long, staging environment's a mess, my tests are flaky. It takes a million years to roll stuff out to the site. I have to do manual security reviews. Tick, 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 all these different things. And unlike when the developers used to just, legitimately complain about those things, now I said, great, you just gave my team our backlog. Yeah. So we just went through all of those impediments, all of those blockers essentially to team being faster, and started removing them one by one, either through automation or helping the team change their processes or building new tools or something like that. So we worked on a bunch of those different things. Again, build time, startup time, much better data and infrastructure availability in our staging environment. We built a thing we call traffic mirroring, which that's our term, but like I've heard other people call it shadowing. So like you have a service a production service, and you fire a request at that, and you also fire a request at the newer version that you're testing, and then you compare the results. So obviously we would have loved to have everybody have done test-driven development from the beginning and have a rich set of tests. But the open and honest thing is, after 27 years of software, there's a bunch of things that are lightly tested or not tested at all. Mostly those things are things that people aren't changing, but neither here nor there. But anyway, so this traffic mirroring allows us to like black box essentially test hey, when we made this framework change or, fix the security vulnerability, did we actually change, the outside behavior of it at all? And that really helped us. And then we built, this is standard technique, is we always had staged rollout for 20 years, being able to roll out things, to the site in a staged way, but a developer always had to click the button to go from one stage to another stage. And well, what is the developer doing? She's looking at some graphs and she's deciding, oh, everything looks good. Okay, it's ready to move to the next stage. And so the obvious thing, which we did, is we put our cool monitoring system together with our cool stage rollout system, and we built a canary capability, again, standard in the industry, where just looking at the metrics, it automatically rolls it out, and if there's an issue, it rolls it back. So all those techniques allow us to just go that much faster. And we started to see the results. So the quick punchline is, after a year of working with those 10% of teams, we were able to double their productivity. What does that mean, productivity, in this context? It's not the perfect measure, but it's maybe the best measure. It's a measure of flow. So it used to be that a given team with the same size and same composition could produce X number of features and bug fixes in a certain period of time, and now they can produce 2X. Yeah. So we've been able to double their ability to deliver software. And oh, by the way, again, I know you know this, but by reducing the difficulty of going through that software delivery process, by automating more things, making them quicker and easier, and so on, we reduced the transaction cost of doing deployments, which made it easier for people to do more deployments, and also reduce the batch size, right? So now the optimal batch size of doing one of those things is smaller. So it means that we're doing smaller units of work. They fit in people's brains. We can roll them out easily. We can roll them back easily. When we roll them out and there's an issue, because that happens a lot of the time, we know what it is because we only changed one or two things, right? As opposed to the previous thing where you batch up a month's worth of work for an entire team, or 2 weeks worth of work, and you got 100 changes in there. And goodness knows what, something breaks and it happens, who knows what it is, and you have to roll the whole thing. Anyway, so, smaller units of work are better in all situations. So we started doing that. Teams are moving more from a branch-oriented strategy to trunk-based development. There are a few teams that are piloting, one team that's piloting pair programming, reduce the lead time around the code review process. So that's where we are. Great.
There's, from my point of view, there's quite a lot of motherhood and apple pie in that stuff. It all sounds fantastic. But the stuff that I would the kind of stuff I talk about on my YouTube channel all the time and advise people to do. It's always nice though to hear about that it really works. I've yet to meet anybody that's actually made this journey, that's made this transition, that would ever want to go back to the old way of doing things.
Oh, 100%. Yeah, I mean the teams are so much. I mean the productivity improvements are more or less self-reported by the teams. Yeah. And again, I mentioned those DORA or accelerate metrics, right? Yeah. Which is, fortunately, I suppose our problem today is software delivery, because there's a whole book and state of DevOps surveys and research that tell us how to improve software delivery. So we've focused on the speed metrics, the deployment frequency, and the lead time per change. And exactly as Dr. Fosgren's research would tell us, and what happened is, by moving those speed metrics, we also moved the stability metrics. We're already quite good actually on the change failure rate. We were down at call it 1% to 2% overall, but now we're way below 1%. For the teams that have adopted these, again, smaller units of work, more automation, et cetera. And then we've reduced the time to recover by about 2 to 3x as well. Again, it was pretty good to start with, and it's even better now. So we were able to move. So what was great is we saw that doubling of the end-to-end flow, or the end-to-end productivity of the teams, but we moved those accelerate metrics pretty substantially. So most of the teams when we started, they were medium performers in deployment frequency and lead time. So say they were deploying, let's call it twice a month and with 10 days of lead time, and now they're deploying twice a week with 2 days of lead time. Yeah. And again, there's way more to go, right? So the ideal, and both of us have experienced it, is deploying multiple times a day with like an hour lead time. So there's a ways to go, but already just moving from that medium performer level to the high performer level, let alone the elite level, made huge improvements in the team's ability to get their work done. They're having so much more fun, and it's better software. It's just better software. So we're doing our job by our customers, a lot better.
Yeah, it's great. It's great to hear that it's having that impact. It's not surprising, but
I mean, like pilot, I always put that in quotes in my head because we knew it was going to work. Yeah. But legit, we needed to prove to people at eBay that, okay, yeah, you can, sure, there's this book and whatever, but like, that's not our software. That's not our problem statement. That's our, the legitimate skepticism that it hadn't been proven at eBay. So the pilot was really all about developing those proof points at eBay. And also, frankly, like, we didn't just like walk in and turn a dial. Like, again, like I said, we asked the teams, what's blocking you? And there were things, like real things that were, problems. And we solved them, or we helped, collaborating with those teams to solve them. Teams solved a lot on their own, by the way. So now we can go to teams and go, hey, there's still a lot of those conversations about what's blocking you, and there are still more blockers for even those teams. But the new teams that we're bringing in, but now we can say, here's a playbook. Like, okay, with your technology, use leverage this deployment pipeline. Use this to tune your build times. Use this to tune your times. Use this, again, traffic mirroring capability, canary capability, et cetera. So now we've built up all these again, this playbook, or these tools and capabilities for teams to use. And
I think that the Accelerate book is one of the most important books that's happened, at least in the last 10 years. Because it puts us on an engineering footing. It gives us a way of just starting to use these metrics as genuine tools for the kind of improvement that you described.
100%. In fact, I so agree. I actually said almost that exact phrase in another interview that I just recently did. I think 100% that Nicole, Dr. Fosgren's work here is the thing in the last 10 years. 100%. I can't think of any more impactful research book resource that, as engineering leaders and engineering practitioners, we would use. It's at the level of the patterns book, in my view. It's a gang of four level stuff. And a lot of us knew and practiced a bunch of those techniques before she wrote the book. She wouldn't say otherwise. She didn't invent any of these things. But the careful and scientifically correct analysis that she did, like the whole second half of the book is, hey, skeptical person, here's the science behind why all these things work, and you can believe it. And that's revelatory because it convinces the people that are on the skeptical or like laggard part of the adoption curve. But also, frankly, just simply the four, there are more metrics in there, but like the four metrics that we talked about, the deployments frequency, lead time, change failure rate, and MTTR, like, we're not having conversations with teams about how to measure their delivery performance. We're saying these are, you should read the book, and I encourage you to do that. But these are the proven things that indicate how well we're doing as an organization, and we're going to measure those, and we're going to use those measurements as opportunities to figure out what to improve, and that accelerated us from debating the measurements, because there's a million debatable, mostly bad measurements about productivity and mindset and all that kind of stuff. And she just accelerated us all, pun not intended, accelerated us all right past all that. So I think we all owe Nicole, Dr. Fosgren, a huge debt.
Indeed, I think it's fantastic work, and to kind of close the loop from where we started our conversation, I think it's one of the things I think in the last 10 years, I've been seeing a genuine move towards something that feels more like an engineering discipline and less like craftsmanship, if I'm honest, craftspersonship. I think that we are, we've got some tools that we know work, and when we wield them, we get better results, and that's what you'd expect from engineering. It's not proof. It's not going to give you a guarantee of success, but it's going to improve your chances of success markedly. If you're using the right tools. And I don't mean that in the sense of compilers. I mean in the sense of these ideas like the DORA metrics and so on.
Yeah, and all the techniques associated with continuous delivery, and we didn't even talk about this, and we shouldn't because we were running out of time. But like transformational leadership and like culture, because like it's not just about technical practices. It's about, oh, by the way, teams have to be able to say the truth. Speak truth to power, and like,
absolutely
other people's opinions. And I mean, yes, I mean 100%. But like I know you know this, but just I think people that are maybe new to this industry that are just kind of experiencing this now, it's like, oh, this is obvious. Well, it was obvious that these techniques were good things. We had no proof until Dr. Fosgren's work that they work. We had anecdotal evidence, but 40 years of research into pre-Nicole, 40 years of research into software delivery, and like nobody could find any, she says this, like nobody could find any correlation or causal relationship between the various kinds of investments and engineering outcomes. And she was able, she and everybody involved in the state of DevOps surveys were able to figure out a way to, separate it. And like, that's the absolute brilliance that like stepped the entire industry up. So I'm 100% agreeing with you that I think now we are on a much more scientific / engineering footing as an industry. And I don't say this lightly, like it's Nicole. She brought us here. Like, she showed us the way. And again, like I say, I think we should be all incredibly grateful for that, because now, survey methodologies and science actually works as applied to software, as we hoped, but couldn't figure out for 4 decades.
And I as you say, for people that are kind of relatively new to the industry, I'm fairly sure he's written it down, but I can remember having conversations with Martin Fowler and him saying it's not possible to measure software teams. I think we all thought that. I think we all believed that. I
did too, because there were all these, not because we didn't know that there were practices that worked better or worse. We knew that, but we couldn't prove it because we didn't have an output. We didn't have outcome metrics or even output metrics. Well, all we had was output metrics. All we had were lines of code and function points and like all the like deeply gameable, horrible metrics that measure actually nothing. And what the beauty of this research is she and the research group were able to find those engineering outcomes distinct from the customer outcomes. So we were like, how do you measure team? Did you satisfy the customer? And like, I still believe, but we were like, there's nothing in between the practice, the stuff that we do. And there's no in between measurement that we believe, right? Between stuff that we do, inputs that we put into our team and our process, and outcomes that we get in terms of customer satisfaction. But what she's shown, and again, that causal relationship among all those things, the brilliance is these engineering outcomes as measured by the four metrics that we talked about. That isn't, these are my words, an interim step where we can, and sometimes proxy metrics, and I mean that in a good way, proxy metrics that we can work in tight feedback loops toward improving those, improving our failure rate, improving our deployment time, improving our lead time. And the research shows that if we do that, we are guaranteed. There is a causal relationship between making improvements to those engineering outcomes and the real customer outcomes that we care about. And I love that you quote all the time, which I'm now starting to do, which is the teams that do really very well on these things do 44% more real work, like 44% work on features as opposed to maintenance or bug fixes or something like that. And again, I know you know this, but like the research shows that the organizations that do this have better productivity, better profitability, better market share. And you need only think of the engineering organizations that you like admire out in the world, again, the Amazons, the Googles, the Netflixes, et cetera, of the world. And they're the one, I mean, they're proof points about like investing in platforms, investing in these techniques, actually doing these practices for serious. They make a big difference. So
huge. You saying about them being kind of proxy metrics, and they are, but they're proxies for things that really matter. The stability measures the quality of the work that we produce. Throughput measures the efficiency with which we can deliver work of that quality. Those are things that matter to everybody. Whatever it is that they're building. So they're difficult to gain. They're not the real value. I've been reviewing a book. I'm writing a foreword for a book that's written by a friend of mine about SRE and the adoption of SRE in a non-Google big environment. I think that might be the other part. That might give you the framework for that other set of metrics in terms of, I'm building this feature. What are the indicators that I need to monitor in order to be able to determine whether the service is good, the kind of your canary, measure or whatever else, or take that further, and what level of objective am I setting for this thing on that measure, and using those as tools to get to more kind of hypothesis-driven development and apply that engineering just a little bit further in terms of testing the customer impact as well as the technical measures. I think most people think about SRE in terms of, uptime and all that kind of stuff, which is fine, but I see no reason why you can't apply the same thinking to, does it make my customer trade more or whatever else?
Oh, yeah, 100%. And again, there's a whole nother podcast in this conversation, but just to quickly 100% agree and underline all the things that you say. SRE, I mean, people might think that SRE is about only uptime and availability. I respectfully, you're wrong.
I know.
I know you know that. But that's way too simplistic. I mean, again, SRE is an engineering discipline as applied to all aspects of reliability and system performance, et cetera. I know you know that. And so the service level objectives that bring together those things, how do I express in quantitative ways a good customer experience? And that's hard. Like, you actually have to use your brain and think about it. Going through this, we're actually implementing a bunch of these things at eBay right now, early days, but it looks great. How long does it take for a customer to, get through this checkout flow? All those seemingly technical measures do actually measure, when done properly. We can actually measure aspects of the customer experience, whether it's error or performance or whatever, that really matter. As a hint to your reader. So I also am doing a blurb, not a foreword, for Vlad's book. So that's exactly, I know. And when that comes out, I'm going to be strongly recommending it. It is just tremendous. Tremendous. This book on implementing SRE. So that when that is out, we'll be talking about that one too.
Yeah, definitely. Out later this year, no doubt. I think we should probably think about wrapping up. We've been talking for a long time, and I know you're a very busy man, and up ridiculously early at this at this point. Although normal for you because you're so busy. But anyway, I'd like to thank you profoundly for having the conversation. I've really enjoyed it. I hope you have too. But I've had fun. It's been really good.
Oh, me too, Dave. Just what a pleasure to get a chance to hang out with you and chat about these things. But as you can see, both of us are really passionate about all this stuff, and just we're tripping over each other, to add to the conversation. So this is one of those conversations I really like and enjoy, and I'm really grateful to you for having me on. Big fan, as I mentioned in the beginning, of your channel and all the work that you do. So please keep it up, and I'm honored to be a part of it.
Well, I'm honoured for you to have taken part in it, so thank you very much. As a wrap up to everybody, thank you very much for watching. I hope you've enjoyed it. I'll reiterate my thanks to Randy for taking part. Fascinating to learn all of those things. I'll put some links in the description below to follow up on any of the stuff, some of Randy's talks and any other things that seem appropriate, and we'll put a timeline into. Thank you very much. Hit like if you enjoyed it. Bye-bye.